Okay, we're looking at algebraic fractions, mini test, and we're on question 3. So we're adding fractions, so that means they've got to have the same denominator before we can add them. And as soon as you see a quadratic, think about whether it will factorise. And here we've got the difference of two squares. So that 4x squared minus 9 does factorise to 2x plus 3, 2x minus 3. Difference of two squares comes up a lot in various types of questions, so it's really important you recognise that. The second fraction just doesn't factorise at all, so we'll leave that as it is. Now, the reason that's important is if you think back to when you were just adding numerical fractions. Let's say you were adding 5 over 4. It doesn't really matter, but let's make them both proper fractions. So 5 over 8 plus 3 over 4. So you could just kind of automatically multiply those two denominators together and come up with a common denominator of 32. So the first fraction would get multiplied by 4 and the second fraction would get multiplied by 8, and that's all good, and it's not a huge problem with numerical fractions, but we haven't gone for the simplest fractions that we could have. And the reason for that is because 8 and 4, well, they share a common factor of 2, but probably more importantly for us, 8 is just 4 times 2. So if I spotted that, I actually wouldn't have to change the first fraction. I could just multiply the second fraction through by 2, and the benefit of that is it's just kept everything, kept all the values as low as they can be, and I then don't have to simplify my final answer. Now that becomes much more important when we're looking at algebraic fractions, because if you don't keep them as simple as you can, you could end up with something way more complicated than you need to, and then if you don't simplify your final answer properly, you won't be able to get full marks. So why is that important? Well, both of those denominators have got a factor of 2x minus 3 in them. So actually, I don't have to change the first fraction at all. So that can just stay as 2x plus 3, 2x minus 3. And that second fraction, if I just multiply that through by 2x plus 3, we've then got a common denominator. So that fraction's been multiplied by 2x plus 3. So to keep it an equivalent fraction, the numerator just also needs to be multiplied through by 2x plus 3. Okay, right, so now they've got the same denominator, so I can just add them. So as a single fraction, it will become 5 plus, and then I'm going to multiply these brackets out. So it'll become 6x plus 9. And that's all over that common denominator of 2x plus 3, 2x minus 3. And there's not going to be any reason to multiply that denominator back out. So you just leave that fully factorised. I do need to then simplify that numerator. So that becomes 11x plus 9. So you definitely need to collect like terms. And then the final thing I would just need to check is whether that numerator then factorises and cancels. And it doesn't, so that is my final simplified answer.